Okay, we will look at a couple more applications of adding vectors using components. So here we have three vectors. Components are useful when you have more than two. If you only have two, you can do tip to tail or components. But if you have three and you did tip to tail, you would have to do tip to tail twice, and that gets a little tricky. So components are useful when you have more than two. Okay, so I have three vectors u, w, and v. So I'm going to make a table to organize my information. So I have vector u, and we're looking for the x and y component. So u is directed vertically, headed north, so all the magnitude would be directed along the y, and there would be 0 on the x. So that one's pretty easy. The w, I'm going to draw a separate triangle for w, separate diagram. So w is going this way at 12. Connect to the x-axis, so we don't want to use the 65. We want to use the angle it makes with the x-axis, which is going to be 25. So for w, we will have the magnitude times cosine 25 and sine 25. So if we type that into the calculator, we get 10.9 and 5.1. Now, that vector is directed left and down, so both components would be negative because that tells us which direction that vector is going. So it's going left and down, so both x and y will be negative. And the last one is v. V, I can see it is a 40-degree angle between the vector and the x-axis, so I'm not going to draw a new diagram for that one. Magnitude times cosine 40 and sine 40. So if we calculate that, we get 6.9 and 5.8. This one is directed right, so positive for the x, but down for the y, so negative for the y. And then we will total to find the resultant components. If we add these values up, we get -4 for the x and -5.9 for the y. So we can use Pythagorean theorem to find the resultant. We'll just do the square root. So we've got -4 squared plus -5.9 squared. And the resultant works out to be approximately 7.1. There are no units given, so we'll just leave that as 7.1. Then we want to determine the direction. So we will use the opposite y over the adjacent. The angle works out to be 56. Now, where is that resultant? So both the x and y components of the resultant are negative. That tells me the direction. That tells me it's going left and down. So that tells me it's going in this direction, because this was -4 and this was -5.9. So the angle we've found is 56 using tan. I would probably measure this from the positive x-axis just to be consistent. So we want to measure it from here, and we want to go around to the resultant, which is this vector here. So I'm going to add 180 to the 56. So my direction is going to be 236. And then I would just describe it as relative to the positive x-axis. I have to describe it from some starting point. And so generally we either use the positive x-axis and go counterclockwise, or we use quadrant bearing. You might use that as well. If you were using quadrant bearing, you might say it's starting at south and headed 24 degrees towards the west. That would be another way to describe that resultant vector. Okay, let's do this one. I'm going to do this one in both methods, and we'll compare answers. We did this one in class. We have a aircraft traveling at a speed of 240 for an hour and 15, and then it turns and heads for another 2 hours. So the first thing we want to do is determine the distance the plane has traveled on each leg of the trip. So 1 hour and 15 minutes is an hour and a quarter, or 5/4. So I'm going to multiply this by 5/4, and we get 300. So on the first leg of the trip, they traveled 300. Same speed. Second leg of the trip, they traveled for 2 hours, so they traveled 480 kilometers. And we want to, so this is A, determine the displacement for each leg. So we found the displacement of the first 2 legs. We need to find the resultant to find the displacement returning to base. So I'm going to do tip to tail first, and then we'll do components to compare. So let's draw a diagram. We'll draw a quadrant here. So the first leg of the trip, they're traveling 300 kilometers north 20 west. So we're going to go north 20 west, which is approximately there. And then from there, I'm going to draw a second quadrant. That will be my starting point for the next leg. It's going north 80 towards the east. So north 80 towards the east is approximately there. So the first leg, they're traveling 300. The second leg, they're traveling 480. So I want to find the angle in between these two sides. We have a Z pattern here. I'll draw this in red. So here we have a Z pattern. We have north, then we have the vector, and then we have another one. There's my Z. So if this is 20, so is this angle. So the angle here will then be 70. And then with this second vector, we have 80, so that makes that 10 to make 90. And so the angle in between is going to be 80 degrees. So we'll use cosine law to determine the magnitude of the resultant. And we're using the angle 80. So if we type that into the calculator, we get a final result of 520 kilometers. Okay, so the total distance traveled is 300 plus 480 plus 520. So 1,300 kilometers. If we wanted to find direction, we can use sine law. Our final resultant is somewhere over here. So we will use the final magnitude of the resultant, 520, over the angle, it's opposite 80. And we want to find this angle, so we'll use 480 over sine theta. If we type that into the calculator, theta works out to be 65.4. Now, we only want this angle here, because this is the angle that the resultant is from north headed towards east. So we'll do 65.4 minus the 20 degrees on the left side, and so that gives us 45.4. So starting at north, headed 45.4 degrees towards the east. So that would be using tip to tail. If we're using components, we'll make a table. We've got the first leg of the trip is 300 kilometers, and the second leg is 480. So the first leg of the trip is north 20 towards the west. So if we connect to the x-axis to find the components, we will use 70 degrees as our angle. And we are going left and up. So this works out to be 102.6. It is going left, so we'll use negative. And then the y component is 281.9. It's going up, so it's positive. The second leg of the trip is going north 80 towards the east. Connect to the x-axis, so we will be using 10 degrees for our angle with our components. So 480 cosine 10 and 480 sine 10. This vector is going right and up, so both positive. We'll find the total of these x and y components, and then we'll use Pythagorean theorem to determine the magnitude. So resultant works out to be 520, which is the resultant we found using tip to tail. Right, back here we found 520. So consistent answer using both methods. If we were finding the angle for the direction, theta works out to be 44.6. Now, what does our resultant look like? Well, both positive, right? The resultant was right 370 and up 363. So we know the resultant is in the northeast quadrant. We use tan to find this angle here, but we want to measure it from north. We want this angle, so we'll subtract that from 90, and it will be north 45.4 towards the east, which is the same direction we got using tip to tail. So both methods are valid methods. One is using tip to tail, one is using components, but both of them result in the same answer, and it's really your preference which method you like to use. There will be some instances where you will have to find components, but for the most part, you have the option of using one or the other. Okay, here we have three vectors. We have a hiker traveling in three different directions. So again, let's use a table to organize with components. So we have the first trip is 500 meters. The second trip travels 430, and the third leg of the trip travels 200, and then we'll total that up. So I'm going to draw a separate diagram for each. So north 30 east is the first one. So we're starting north, and we're headed 30 degrees towards the east. So connect to the x-axis, we will be using 60 as our angle, and the magnitude cosine of 60 and the magnitude sine of 60. So that calculates to be 250 on the x and 433 on the y. Both are headed in the positive direction. The vector went right and up, so both of those components will be positive. The second leg describes it a little bit differently than I like to, but it says it's going east towards the south. So we'll go with that. So 40. So headed east, 40 degrees south would look like that. So we're going to use the 40. So 430 cosine 40 and sine 40. That works out to be 329.4 and 276.4. The X we're going right, so that's positive, but the Y we're going down, so that's negative. And then the last leg of the trip, they're going north 10 west. Draw a different axis here. So we're going north, headed 10 degrees towards the west. So connect to the x-axis, we will be using the 80-degree angle. And that works out to be 34.7 and 197. We are going left on the x, so that is negative, and up on the y, so that is positive. We'll total that up to get the components of the resultant. Both components are positive, so that tells me that the resultant is over here in this direction. It's positive 544 to the left and 353.6 up. Okay, so let's find the magnitude of the resultant. We'll use Pythagorean theorem. And the magnitude of the resultant works out to be 649.4 meters. So that is the magnitude distance that the hiker is from their starting position. And then we want to also find direction. So we'll determine the angle. So the angle works out to be 33 degrees, which is this angle that we just found here. But we want to measure it starting at north. So we want this angle because we want it in quadrant bearing. So we'll subtract that from 90 and we will get north 57 towards the east. So we'll use quadrant bearing just to be consistent with the way the information was presented. Okay, let's do one more. Let's find